Good afternoon, ladies and gentlemen. As the last keynote speaker of today, I'm thinking that what kind of things I can talk just to attract your attention, to awake some of you. So today I want to talk something about AI and 5G, put them together. So I name it, it's an autonomous driving mobile network. So from today's, we have quite several keynote speakers mentioned about 5G, mentioned about AI. So, but what's the relationship between two of them? So now this is what I'm going to talk about. In the past 3 centuries, actually our society has been experienced 3 industrial revolutions, which are about mechanical revolution, electrical revolution, and information revolution. But it's time to go to our 21st century. If we found one technology which is comparable with the previous 3 industrial revolutions, I think that is intelligence. It's artificial intelligence. So in the artificial intelligence era, I think it's probably we can expect that in the coming 10 years, we can enjoy the driverless car. But it's, today I'm not going to talk anything about the car, but I'm going to talk something, can we also enjoy the driverless mobile network? So actually, in October this year in Shanghai, Huawei released our AI strategy. Actually, we released our full stack all-scenario AI strategy. When we talk about full stack, means that Huawei is developing this full stack AI products, which include the processor, also the processor enablement, also the developer enablement, and AI application. Meanwhile, also we are investing about the AI talent. So when we talk about full scenarios, we mean that is our AI technology will apply in all the scenarios which cover from the edge computing, the private cloud, public cloud, and also our telco network. Within Huawei, that in the past, let's say 2 years, we are working on a project we call Softcom AI. If you are familiar with Huawei, probably you heard about our strategy, like the all IP strategy, all cloud strategy, on all intelligence. More than 10 years ago, Huawei we said all IP. We are following all IP strategy. All IP really changed a lot about our telco network. 5 years ago, we started to talk about all cloud, which is target to build this data center-based telco network. And around 1 year ago, we talked about Softcom AI. Means that we want to introduce the AI into our telco network. We target to build this full autonomous telco network. So why we need to build an autonomous telco network? Let's take example of the mobile network. Thanks for our technology is investment. Actually, you know that now on our mobile network, we have 2G, 3G, 4G, and then we have so many different kind of bands. We have different technology together. So now we are going to add on another layer we call 5G. So imagine that on your site, there will be so complex, so complex. We have 4 different red technology. We have the more than 15 different kind of bands. Also, we have a lot of different kind of sites. And also, we have a lot of different kind of services. So it is more and more difficult to improve, to optimize our network. It's more and more difficult to, provide the best user experience. So if we still follow the traditional way to manage, to operate of our mobile network, it will be consume a lot of human effort. As also, we are worried about that. It's due to the cost to invest to build and operate the network and higher, and also power consumption. Meanwhile, that is, we cannot expect we have the similar growth from the revenue side. Means that is we cannot find the right business model. So we have to figure out a new solution, a new way to deploy it, to manage it, to operate the mobile network. This is why I'm talking about is we need to introduce the AI into our mobile network. So if we look at the mobile network, actually we have the special character when we think about how to make the network is autonomous. So first of all, most of the data from the mobile network, they are structured data. And also, it's thanks for the technology improvement. Actually, the base station has a more and more powerful computing capability. So if we assume that is we have the 10,000 size network, the computing capability of the base station is more or less like 5,000, the very latest server. And also that in the worldwide, is most of the operator, you have more or less 30 years of the experience to build and to operate this mobile network. We have a lot of fantastic experts on mobile technology, no matter from the vendor or from the operator side. So I have a lot of skills. We need to really gather all the skills together to operate the network in the best way. On the other hand, also that we have the mobile network also have its own characteristics, such as most of the data, there are time-sensitive data. And also the mobile network is a distributed architecture. And then also we have so many different kind of scenarios. When we think about to build autonomous driving mobile network, we have to take all of this kind of information into the consideration. So actually, last month in Geneva, actually we have the similar forum, but which was about the fixed network. In that forum, the first time also I released our idea about to build autonomous driving network. This was what I presented in Geneva. Actually, to follow the similar concept like this autonomous driving car, actually we define it's a level 0 to level 5, the different kind of let's say, autonomous driving level. The basically say that is level 1 is just like assisted automation. It's based on rule-based execution. Level 2 is a partial autonomous driving network, and then it apply adaptive execution. And then level 5 is our target, will be fully autonomous network. If you look at that, it's for the different level, it can provide the different functionality of the autonomous. It's a target to release our hands and also release our brain. We want to make this network operation and network and also service provisioning is more and more easier. We want to reduce the requirement of the skills and also workload of the operation and maintenance engineers. So if we have a look at the architecture, how we can achieve this kind of this autonomous driving network. On the left side, you can see this is the architecture of these autonomous driving cars. To achieve the fully autonomous driving cars, actually there are 3 layers. The one layer is about on the car, you have so many different kind of sensors which can real-timely to collect information of regarding the car, also the surrounding the car. And then it is you have the control and the analytic system in the car, which can deal with all this kind of information and figure out the right strategy which the car can use. And also on the cloud side, they need to all the different cars should be linked together. Also, there are some strategy which can input and transfer to the car, which car can use it, and then to do the faster inference. So similarly, we can define the similar architecture for this autonomous driving network. Actually also includes sensor, which we can build of a different kind of network elements. And also we need to build this kind of let's say, analytics and control system in the domain layer. And then also we need to build this platform which can do the AI training on the cloud. So this is basically the structure to achieve this autonomous driving network. So specifically, let's have a look about mobile network. As today's, all of us, we have experience to build and operate this mobile network. For the mobile network, also, we need to think about how we can really build intelligence into the network. Firstly, we need to think about how we can really build this edge intelligence. This means that we need to build intelligence into the base station. The second that is on the network level, probably to cover the whole London, you need to 3,000, maybe 4,000 sites. So how we can, for the whole city, we can build this kind of a centralized, it's an analytics and a control system. Here we named as mobile broadband automation agent, which can realize similar functionality like this. And then above that, we need to build a cloud-based intelligence system, which can collect information of the different layer or different domain of the mobile network, which is covered from both the radio network, the core network, service network, and also backhaul or backbone. Collect all this kind of information, and then they can do the further about training, which can generate this kind of a different kind of policy, and the further input to or transfer to the, let's say, MAE, which could do the further inference. And then also, let's need transfer again to the edge intelligence, to the sites, to the base station. That base station can really execute this kind of a, let's say, intelligence model or intelligence policy. So first, let's look at this, the AI platform on the cloud. Actually, for this platform, they have several inputs. One input that can get the real-time input from the domain layer, also from the site layer. The second that is, this platform can get information also from the people behind that. Due to that is almost all the operator or even all the vendor, you have a lot of very experienced people. People can input their know-how into this. And then this cloud-based of the AI platform, it could generate a lot of its algorithm, also model. We can transfer to the domain layer. And also for Huawei, that due to that, we are serving more than 400 operators. And also, our technical support people, they're operating more than 150 mobile networks in the worldwide. Actually, we have a lot of know-how about how to operate, how to optimize of the mobile network. All of this, it could be input to this AI platform. It's a cloud-based AI platform. So it's using this kind of a platform, we can directly to connect to the domain layer, and also we can provide it as an AI as a service. The second that is about the network AI. Network AI, it is at the mobile network domain layer of the AI platform. On this platform, first that it can collect the data and the status from all the mobile, from all the base stations, also from the network domain. We can do data analysis and also inference, which can recognize the different kind of scenarios, and also to predict or to prevent some risk from the network. And then it can analyze the status of the network, and which can make the final decision. To make this, the mobile network to go to the autonomous, they need two critical transformations. The first one is the network itself should transfer from this network element centralized operation model to the scenario-oriented operation model. The second that is, at the network layer, they should transfer from the pure management, pure O&M functionality to the management and control convergence operation model. It's two critical transformations to realize this kind of functionality. So this, the convergence of the management and the control, which can realize is further more precise this network optimization, and then also the network planning and design, and also deployment, and even the service provision. So talk about the intelligence on the site level. So the site AI, first, is based on embedded system. It can realize this machine learning, deep learning, and also is algorithm. It supports algorithm platform. So on the site, there are two important capabilities. The first one is data extraction. The second one is to execution this kind of inference. First of all, the site could execute this kind of inference according to embedded the AI policy, which is transferred from the domain layer and even also from the cloud-based AI platform. So through this site AI, we can realize the real-time scenario mapping, and then fulfill this autonomous functionality. So just now could be a little bit technology details, but let's back to what kind of things we can do. Actually, as an operator, and we all know that. And then, in our daily operation, we have to deal with the network planning, and network design, deployment, and optimization, operation maintenance, and also it is service provision. Actually, when we talk about network autonomous, we need to realize from all of this, it's a scenario by scenario. But for sure that our target is to, to realize the full scenarios of the autonomous. But it's very difficult. Actually, what we suggest is following a practical way to start from scenario by scenarios. Let's pick up some most typical scenarios which can apply this kind of autonomous methodology and to realize this autonomous in the specific scenarios. This is also just like what we are experiencing in the car area. Actually, we all know that it's for some of the cars, such as Tesla, that can realize this automatic parking functionality. In that specific scenarios, the car is realized it's automation. And then we can use a similar idea in our mobile network. We pick up some scenarios. We can realize this kind of automation in that kind of scenarios. So the further step, we can is link all the scenarios together to realize really closed loop, this full automation. That could be the further step. So to make it more concrete, let's have a look about two cases. The first one it talk about is VoIP service provisioning. As we all know that VoIP will become one of the basic service for the IoT network. And then it's very soon when the 5G comes, also we should support is voice over NR. But to deliver the VoIP service is quite complicated. Actually, on the network, you have more than 60 different kind of parameters to configure. You have this always to deal with this kind of a weak coverage. That is to support VoIP, they need 5 dB more of the better coverage than a normal mobile data. And also, you have to deal with this kind of more than 10 different kind of network elements. But using this kind of let's say, automation functionality, firstly, we can learn about this relationship among the different kind of parameters. We can realize this kind of alter parameter configuration. And also that is when there are some trouble or some problem happen about the weaker coverage, and then the system can detect what's the root cause, and to fine-tuning the parameter of the network to improve the coverage. And then in case of that, is some, a complaint happen or problem happen, the system can do this kind of automatic fault handling. Actually, to realize all this kind of through functionality, there are a lot of different kind of algorithm. It's a need to support it by the system. For example, to support this kind of alter fault handling, they need to use the Q-learning as an algorithm to do that. You're using all this kind of let's say, automation functionality, which can make this kind of VoIP service provisioning much more easier, and then it can reduce the requirement of the human effort. The second case is about how we can make the message memo much more smarter. As we all know that message memo will be one of the basic functionality for 5G. It is critical for 5G. But due to the complexity of the message memo, it is a very heavy job for the planning, deployment, and even also for the optimization. Because it's a message memo, the support is a might beam. The might beam also bring a lot of flexibility. Meanwhile, also it is a lot of complexity to manage the beam. So Huawei now we are working on this kind of smart MIMO solutions, which can realize we can make this mass MIMO network planning, deployment, and optimization much more easier. Just several points I want to mention to you. The first one, we put the GPS receiver or detector on the antenna, on the active antenna, which can make this, the network can recognize, can do the parameter configuration or fine-tuning automatically. And second, that is we apply this, this new functionality on the phone and also on the network, which can make the driving test and then make the network can automatically detect the different kind of information and also to realize the closed loop control. So let's have a look about how we can realize this kind of a mass MIMO in the more smart way, and how we can, let's say, using smart mass MIMO to build the 5G autonomous. Please. So actually, it's quite complicated to realize the target. It's to build this fully autonomous driving mobile network. To make it more practical, is as what I mentioned just now. Probably we can start from specific scenarios. Let's take a look at the most typical scenarios of our network, like network planning, deployment, maintenance, optimization, and service provisioning in the 5 typical scenarios. And then to define that, what kind of things we can do at the first step and which kind of a target we can realize at second step. Let's do it step by step. So afterwards, after a few years of let's say working that, we can realize that's a level 4 of the autonomous driving network, and then step by step to the final step. To make it more, let's say, concrete, please have a look on your desk. You have the white paper, which is about the key scenarios of the autonomous driving mobile network. Actually, we have a much more detailed description of that, what kind of scenarios we can support in the next year or maybe next few years. I hope that, and then we will keep update to you about Huawei's progress to build this fully autonomous driving mobile network. So actually today, this topic is quite complicated even for myself. Actually, in the past half a year, I talked with a lot of people from my team, from our team, R&D team. We think that in the past 30 years, we are, working very hard to build a more and more complicated telco network. And today, the telco network already is so complicated. We need the whole team to operate, to maintain this network. And then we have the higher and higher OPEX, which cover that more and more is a human effort. And also which cover is a bigger and bigger power consumption. And then, but what the network can support is still the quite basic connectivities, throughput. But if we compare that is our competing technology or competing players like the OTT guys, they are doing much more their easier job. Actually, for sure that they take the advantage of our effort. So we need to do some change. So thanks for the new technology like the AI. We need to think about how we can apply this AI to further change our network from architecture to the operation and the maintenance model. So that Huawei would like to work together with all the stakeholders in our industry. We need to firstly to set up the common target. The second that is we need to work together to define the framework, to define the architecture. And especially for the mobile network, we can take the advantage of the 3GPP as a platform to define this kind of a target and also architecture of the autonomous driving mobile network. Let's work together to realize this target step by step. So let's build a fully autonomous driving mobile network, which can improve our business efficiency, improve the network performance, and then also build a better business. Thank you.